In this video, we will see the difference between DFA and NFA. Let us revisit the concepts of NFA and DFA to make it more clear. As we already know, the DFA is having a deterministic transition. That means for every state and symbol pair, there exists only one arc. So from one state, if we read one symbol, then only one movement is possible. For example, from state Q, if we read A, then either we will remain on the same state or we might be moving to some other state, but there will be only one transition for each state and input pair. In NFA, we can have 0, 1 or more transition for a single state symbol pair. So there could be multiple such transitions. From state Q, if we read A, we might be moving to state P1, P2, P3 or PK. So these moves are non-deterministic. If we are in Q and we have to scan some string starting with A, then we might be moving to P1, but which may be a wrong path. So we have to backtrack and we have to follow the other path. So there is a non-determinism in NFA. So we can write the delta transition function for NFA in this way. Delta of Q comma A is equal to, now it would be a set of states instead of single state, that is P1, P2 and P up to Pk. All possible states we can move from Q on reading A. Let us see one example. Language L contains all the strings W over alphabet A and B such that W contains the substring AA. So all the strings which are having AA as its part would be in L. So A and B can be either before AA or after AA. Any combination of A and B we can have before AA and after AA, but AA must be present in the string. So these are the some of the strings in language L. Let us first construct DFA for that. So Q0 is the initial state. The minimum length string is AA. So we must have to read AA because the string must contain AA. Now we will adjust the arc so that we can produce all possible strings. From each state, we have to evaluate two input symbols A and B. From state Q0, arc of A is already there, arc of B is missing. So we will start with the closest or the smallest possible arc. So can we have self loop of B on Q0? Is it possible, or will it generate all the valid strings? Yes, definitely it will generate valid, because from Q0 we will be reading n number of B's. And to go to Q2, we must have to read AA. So AA will be definitely part of all the strings generated by this DFA. So arc of B is valid. From Q1, arc of A is already generated. We have to adjust the arc of B. Can we have arc of B as a self loop on Q1? No, it won't be valid, because otherwise we can read A from Q0 to Q1, B from Q1 to Q1, and again A from Q1 to Q2. So that will generate string ABA, which does not contain AA. That means self loop is not possible. We have to check for the now next neighbors. So from Q1 to Q2, if we put arc of B, then from Q0 we can read A and B and we will be in final state. So string would be AB, which is accepted, but it is not in language L. So that is invalid string. So we cannot put arc from Q1 to Q2 as well. But we can definitely put arc of B like this. So once we read B from Q1, it will go to Q0. And to go to Q2, we must have to read consecutive A. Then only we can reach to Q2. So all the strings generated by this DFA will definitely contain AA as a part of string. And in Q2, there is no transition and we have to adjust both the arc. So can we put A and B as a self loop? Yes, for sure. Because when we are in Q2, we already have read out AA. So after that, we can read anything. So this is the DFA, where for every state and input symbol pair, unique transition is there. Let us trace some string ABAA for this DFA. So initially we are in state Q0, first input symbol is A. So that transition will lead us to state Q1, as we can see in transition diagram, and A is already consumed. So now we are in state Q1, input symbol is B. So on reading B from Q1, we are moving to state Q0. From state Q0, if we read A, we are going to state Q1. From Q1, if we read A, then we are moving to Q2. And entire string is consumed. So now we are left with epsilon. When we are having epsilon as an input, and we have to check whether whatever state we are in is final state or not. So Q2 is right now final state. It says that the string is accepted. This is a valid string, or the string belongs to the language. Let us consider now NFA for the same language. So Q0, we must have to read through A. Before this A, we can read any string. After this 2A, we can read any string. So we can have an arc of AB here, arc of AB after Q2. This is NFA. As we can see that from Q0, if we read A, there are two possible moves. Either we remain on Q0 or we are moving to state Q1. So this is a non-deterministic finite automata. Both will generate same set of strings, but the construction of NFA is simpler. Let us trace the same string for NFA now. So from Q0, when we read A, there are two possibilities. Either we move to state Q1 or we remain on state Q0. Fine, because there are two moves from Q0 on A. Q1B is not defined. There is no transition from state Q1 on input symbol B. So this move is rejected. So we have to backtrack and we have to go back to the Q0, B double A. From Q0, if we read B, then we will remain in Q0 state itself, and we have a 2A remained into the string. Next, from Q0, if we read A, there are two possibilities. Either we will remain in Q0 or we will move to the Q1 state. From Q0, if we read A, we are again there are two possibilities. We will remain in same state or we will be moving to Q1. And in both the cases, entire string is consumed. But Q0 is not a final state after scanning entire string, so that will be rejected. We have to backtrack and we'll go back to the next possible option, that is Q1, epsilon. Q1 is also not final state and entire string is consumed, so this is also not a valid move. We will go back and we'll explore the another possibility, that is Q1, A. From Q1, if we read A, we are moving to Q2 and our entire string is consumed. And Q2 is a final state, so this is the accepted path. So as you can see that the scanning of string is quite faster in DFA, whereas it could be very slower in NFA, because NFA could have lot of non-deterministic moves. So we might need to do backtrack and we have to follow the another path to check the validity of the string. So that is the fundamental difference between these two automata. As discussed, the transition from a state is always a single state in case of DFA, and transition from a state can be multiple in case of NFA. Due to the deterministic moves, it is difficult to design. As we have seen that we have to adjust lot of arc, we have to take care that that should not be multiple arcs for a same input from a same state. So that will take a bit of thinking. Whereas in case of non-deterministic, due to non-determinism, it's easy to design. We can simply put the arcs. We have already seen in last slide. DFA can have more number of states, whereas NFA would have less number of states. So once we construct NFA and when we convert it into DFA, then DFA could take many states. So if NFA has n states, DFA can have a 2 power n states. So a number of states or memory requirement of DFA is more compared to NFA. So that's what I said. It requires more memory due to more states, and NFA requires less memory due to less states. However, time taken to scan the input is less in DFA compared to NFA, and it is easy to find whether any string W belongs to L because of deterministic paths. And it is equally difficult in NFA because we need to perform backtracking at many places because there are many parallel paths, whereas in case of DFA there is only straight path. And finally, the transition function for DFA is defined from Q cross sigma to Q. That means we are in some state Q and we are reading some alphabet symbol from sigma, then our move will be one state from the Q only. Whereas in case of NFA, the transition function is Q cross sigma to 2 power Q. That means we are in some state Q, we are reading some input alphabet from sigma, then we can move to any subset of Q. That means it's a power set. We can move to 0 state, we can move to 1 state, we can move to 2 states, 3 states, up to n states. So 2 power n movements are possible in case of NFA. So that's all about the difference between DFA and NFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.